joining us today. My name is Jeff Bowles. I am the Risk, Safety, and Industry Relations Manager for Pigeon Mountain Industries and the host of today's PMI Technical Webinar Series webinar. Before we begin, I want to address some housekeeping items. All attendees will be muted during the entire webinar. We will have time at the end of the presentation to answer any questions you may have. For questions related to the presentation topic, you may type in and send questions at any time during the webinar. You may use the chat function, which is separate from the questions function, for any other comments that you may have. The webinar will last a total of 1 hour and 15 minutes. If you are having trouble with your sound, you may switch from computer to phone or the reverse as needed. Okay, let's get started. Today's presentation title is Rope Access, Fall Protection, and OSHA Regulatory Updates and You. This presentation will outline recent updates to the recent OSHA Fall Protection Regulation, as well as developments within the ANSI Z359 family of fall protection standards as it relates to rope access. Presented by PMI's Loui McCurley, who has been blazing new trails in safe work at height for over 3 decades, this is a command performance update to her presentation at the January 2017 SPRAT conference. From working as a rope access technician before such a thing existed in the USA, Loui visualized and instigated the founding of the Society for Professional Rope Access Technicians in 1996, then went on to help develop a pair of groundbreaking global rope access standards with International Standards Organization in 2003. 10 years later, she worked tirelessly with OSHA to ensure allowances were made for rope access in the impending 2016 updates for their 29 CFR 1910 Subpart D Walking Working Services Regulation, and recently released the first book of its kind on professional rope access for safety professionals and program managers. Today, in addition to serving as Regulatory Assistant Chairman of SPRAT, Loui is once again leading the charge for the cause as a chairman of the ANSI Z359's committee's forthcoming standard on rope access. Louis' commitment to passion to improving safety at work at height is recognized by regulatory authorities, standards organizations, and corporate safety professionals worldwide. You'll get the latest critical updates and insights towards future efforts. Without further delay, I present to you Loui McCurley.
Thanks, Jeff, and thanks to all of you who have taken the time to be here today. We're going to cover a lot of ground and encompass some of the hot buttons that have come up regarding the last year's modifications to the Walking Working Surfaces document, both subparts D and I. So hang on to your hat. But that said, if there are any things in that I don't bring up in this presentation, I would encourage you to go ahead and enter in any questions that you might have to the questions box in your control panel there on the right. We've gotten a lot of questions on these documents in the last few months, and specifically how they relate to rope access, but this is by no means all-encompassing. There's a whole lot more in the rule than I'll ever be able to get through any day, much less today. So as I said, you just enter your question in, or you're always welcome to contact us here at PMI anytime as well. So let's just get started. We'll start with a baseline understanding of where we come up with information about fall protection systems, and as employers specifically, what resources we have at our disposals as we develop the comprehensive managed fall protection plans that we use. First and foremost that we're going to address today are the OSHA regulations. Now, OSHA regulations apply only in the United States, obviously, to U.S. employers. They don't apply outside of the United States, but most other countries have some version of occupational safety and health administration. Some of the rules differ. Most of them are fairly consistent, but some of the rules differ, especially in relation to fall distances, connection points on harnesses, and user weights. We tend to have among the higher user weights in the United States. And so when you see a product or equipment that is not rated to U.S. standards, keep that in mind, particularly if you have heavy workers. So OSHA regulations kind of define the minimum safety requirements within a given jurisdiction. We'll talk a little bit more about that in a minute, but let's also talk about industry standards, how those relate to OSHA regulations. So industry standards are specifications or guidelines that are used to measure compliance. So for example, OSHA might say 5,000 pounds, but OSHA doesn't write a test method, so what that 5,000 pounds means has to be determined by some other method. So that's where we use industry standards. Industry standards such as ANSI A10 or ANSI Z359 are the kinds of guidelines that are used to measure the performance. And then finally, we have industry best practice. There are certain things that we use in fall protection that are not necessarily written into either standards or regulation yet. And so as progress continues and as the world turns and we get smarter and get more equipment and better ways of doing things, industry best practice tends to kind of be the leading edge, and then industry standards follow, and then eventually OSHA regulations, which take a whole lot longer to change. So today we're going to talk about all of that a little bit with a focus on the OSHA regulations, again, specifically as they relate to work at height and rope access. Now, OSHA is a function of the U.S. Department of Labor, as most of you know, and contrary to popular belief, OSHA doesn't exist to write citations. OSHA exists to ostensibly prevent work-related injuries, illnesses, and deaths. OSHA was established back in 1970 to achieve its goals by establishing protective standards, enforcing standards, and then providing technical assistance and consultation. That's not necessarily the OSHA that we all know and fear. That kind of proactive approach is not something that some of us really understand about OSHA, but we need to understand that their mission is to protect employees. And at the time when they were created, especially back in 1970, that was very definitely a real need. I'd also like to point out that OSHA is big. There are inspectors, investigators, engineers, doctors, standards writers, all sorts of technical support in multiple countries throughout, or multiple offices throughout the country. So what that means is when you ask somebody in OSHA for an interpretation of something, or you ask them a question, the answer that you get from one guy might differ from the answer that you get from another guy. And that can create something of a challenge. So if ever you're looking for a specific interpretation of something, you really need to go to the OSHA website and see if such exists on the subject that you're writing on or studying. And if it doesn't, write them a letter and you can actually get an official interpretation. So OSHA has jurisdiction over pretty much all workplaces. Now, there are some exceptions to that. Most of the exceptions have to do with whether or not a person is a government employee. So government employees are exempt. There's also a few exempt industries. For example, mine safety, ships at sea, flight crews in the air, etc. Family members working on their own family farm are not covered by OSHA. Self-employed sole proprietors are not covered by OSHA, and volunteers are not covered by OSHA. That said, most of the OSHA requirements are reasonable enough that industry best practice dictates that we really ought to comply. So OSHA has this thing, this catch-all phrase that they have in the foundation of their regulations, and this is called the General Duty Clause. This phrase essentially says, we're not going to make specific rules about every possible hazardous condition out there, So the onus is on you, Mr. Employer. You have to ensure that your workplace is free from recognized hazards. So there isn't always a specific standard or guideline within the OSHA regulation that covers you, but even so, the onus is on you to provide a safe place of employment. I'll also point out here that there are some OSHA-approved state plans. Most of those are fairly consistent with what federal says, although there are some that are a little more stringent, and we won't go into that at all today. The idea behind OSHA regulation is to protect this guy. The onus is on employers to take care of the employees who can't or won't take care of themselves. We can't assume that either an employer or an employee is always going to do the right thing, that they'll always make good decisions, or that they'll always know what they're supposed to do in any given situation. So with the lowest common denominator in mind, OSHA regulations provide a guide for a safe workplace and a baseline to which to train people. I'd also like to just mention that there is a specific duty clause in OSHA that also says that where things are written into regulation, you do have to follow it. Now, one of the topics that OSHA covers fairly thoroughly in multiple places is fall protection. Fall protection is covered in both 29 CFR 1910 and 1926. That's general industry and construction, respectively. So the complicated thing is that the rules in these two places have sometimes not said the same thing, and in fact, sometimes they've actually contradicted one another outright. So that's part of why OSHA wanted to do this new revision in Subparts D and I. They wanted to harmonize general industry rules more with construction rules, and as we'll see, they've done a pretty good job of that, at least in some cases. One of the questions I get a lot is, what does OSHA say about rope access? Now this one's kind of easy because the answer is nothing in particular. There tend to be two reactions to the answer, OSHA says nothing about rope access. One is, cool, that means I'm not covered. I can do anything I want. But the other reaction is the assumption that I can't use rope access techniques at all. So as we'll see and as we'll study later in this presentation, neither of these statements is true, neither of these approaches is true. The truth falls somewhere in between. Let's go back for a moment to voluntary consensus standards. We pointed out earlier that these are useful in helping us to comply with regulation, but we also need to understand that voluntary consensus standards are useful in providing guidance or context where no regulation exists. So OSHA Fall Protection Regulations, especially the newest rendition, is very performance-oriented. It doesn't include a lot about specific procedures or, as I mentioned earlier, about test methods. So this is where industry standards come in. But keep in mind, industry standards are generally a baseline for industry best practice. You should consider them to be the minimal requirements, not the ultimate goal. So here's some of the consensus standards that are applicable to fall protection. Again, this is not an all-inclusive list, but it will give you an idea that there are some resources out there. ANSI Z359 is probably the most recognizable of all. The ANSI Z359 family of standards covers safety requirements for personal fall arrest systems, subsystems, and components. I refer to it as a family of standards because there's about 18, no, there's more than that, documents within the family at this time, and more being added pretty much every year. ANSI Z359 is specifically directed at general industry. ANSI Z459 is an outgrowth of ANSI Z359. At one time, ANSI Z359 had a subchapter called Z359.8. That .8 document was deferred to a new standard number, and that standard number is ANSI Z459. That document is currently out for ballot in the Z359 committee. It is still administered by that committee, but it won't actually be a standard for some time yet. There are the ISO standards that are applicable to rope access and to fall protection. There's the ANSI ASSE A1032, which are construction and demolitions operations. Again, we try to harmonize as much as possible between construction and general industry, but that's not always possible. ANSI A1048 is relatively new. It just came into practice a couple of years ago, and it is specific to construction, demolition, modification, and maintenance of communications structures. 2505, ASTM E2505, is an ASTM standard for rope access in building maintenance. It is specific to building maintenance, and it is a fairly short standard as well. The IWCA ANSI I14 is not specific to rope access. It actually includes some rope descent systems, but it was withdrawn a couple of years ago. It was specific to window cleaning safety, but as we'll see, there's still a lot of remnants out there from the I14 floating around in the workplace. So since we're talking specifically about rope access today, I do want to point out that there are some of these standards that are specific to rope access that are good resources for you if you do rope access work or are administering rope access work. And we're seeing more of that now, where a workplace will have a comprehensive managed fall protection program that incorporates rope access as well as conventional methods. So the purpose of this presentation today really is to review some of those new requirements in subparts D and I, specifically about personal fall protection systems, fall arrest systems, and rope descent systems, and then to discuss the goals for future rope access and regulation. And we'll talk about the role of industry best practice as well as voluntary consensus standards, in addition to how rope access merges into subparts D and I of the current rewrite. So, to the current rewrite. The 2016 update is the first update in 30 years to this regulation. How much has technology changed in 30 years? Well, quite a bit, it seems. So the 2016 update, OSHA takes into consideration a lot of the modern equipment and methods that we use, and they addressed both subparts D and I. The regulation applies to all elevated walking and working surfaces. It addresses fall protection systems, and it increases performance-based language. I think this is probably one of my favorite things that it did, is to incorporate more of a performance base rather than saying you have to connect connector A to anchor B and everything has to work in this linear perfect fashion, because we know the real world doesn't operate that way. The other thing that they did well is they attempted to harmonize with the 1926 construction rules. Now, as we get into this, keep in mind that I did not write the rules. I'm just sharing some of the information with you here, so don't shoot the messenger. But that said, again, I do think that OSHA is on a great path with their performance-based approach. So the new 29 CFR 1910 Subpart D 2016. The Subpart D includes revised and new provisions that address fixed ladders, rope descent, fall protection systems and criteria, and training. So that's all really good stuff in Subpart D. Subpart I is more about the gear. It adds new requirements for the design, performance, and use of personal fall protection systems. So these two subparts work hand in hand, and they actually cross-reference quite a bit with similar information. So that's how I haven't picked it out paragraph by paragraph here, because D and I are so interrelated that it would be very repetitive. So I've just taken kind of some high-level topics and we'll address them in that way. The first and foundational part of OSHA's provisions that we have to understand is the definition of fall protection. Now, I know that kind of sounds pretty basic, but many people's minds immediately jump to the idea of fall arrest whenever somebody says fall protection. So let's be clear on this up front. Fall protection refers to any equipment, device, or system that prevents an employee from falling. That's it, or that mitigates a fall. So fall protection is this all-encompassing concept that incorporates not just the individual personal fall protection systems, but everything that prevents the employee from falling from the elevation or mitigates the effects of the fall. A personal fall protection system is a specific system that an employer uses to provide protection. So things like personal fall arrest, positioning system, travel restraint. By the way, rope access is a personal fall protection system. It is a type of personal fall protection. So here are OSHA's definitions of some different types of personal fall protection systems that are in the standard. Travel restraint is essentially a leash. Travel restraint prevents the worker from ever coming into a fall potential. Positioning is a system of equipment that allows an employee to be supported. So he's more or less in fall potential because he's leaning into a system, and if that system went away, he would fall. So it's positioning. Personal fall arrest is a system that is used to arrest an employee who is in a fall from a walking working surface. So positioning, for example, has to be used with personal fall arrest, because when you're in positioning, that's just a type of system that still leaves you with, if that system fails, it leaves you with a potential for a fall. So positioning is always used alongside personal fall arrest. Rope descent is a suspension system. It's different from a positioning system. Rope descent is not a positioning system. It is a suspension system that allows an employee to descend in a controlled manner and stop and start. Now, rope descent systems do not include industrial rope access systems. This actually says this in the OSHA regulation and in their definition. So we'll talk about that here in a moment. But just to give you a visual picture here, graphically speaking, if this whole slide is fall protection, all the white background and everything, if that's the canvas that comprises the whole world of fall protection, the specific systems that are named along the lined circle of personal fall protection systems, those are personal fall protection systems. So travel restraint, positioning, fall arrest, rope descent, all of those are named in the OSHA regulation as types of personal fall protection systems. Now on this one, I want to acknowledge that some parts of the regulation apply to fall protection as a whole, that whole big white background, while other parts of the regulation are specific to certain types of fall protection systems. Now note that not all types of fall protection systems are named, and I'll call to your attention here rope access. Rope access is not specifically called out with its own sets of rules and regulations regarding fall protection, but the requirements of rope access, we still have to follow the general fall protection rules, even though we're using rope access. We're going to get a little more into that here. So let's talk first about conventional personal fall protection systems. Here's some examples. Fall arrest is, you can see there's slack. The guy's feet are on a ladder rung in this case. They might just as well be on a walkway or a platform or one of those beams. He's standing on some sort of a system, and he has the potential for a fall. The lanyard that's connected to his dorsal attachment is going to catch him in the event of that fall. So that is his personal fall arrest system. In the center image, you can see positioning. The positioning, the guy in positioning is using the ladder as his primary means of support, but that little bum bag, if you will, is his positioning system. He's leaning into a ladder rung, and then the upper connection that looks like an SRL in this case, that's attached to his dorsal attachment, that is his personal fall arrest system that he's using in conjunction with his positioning system. So that's sometimes the most confusing for people. And then the final one on the right is restraint. So that is a restraint. It's a leash that prevents him from ever reaching the leading edge, and he can't possibly fall over. So let's talk about rope descent, because rope descent is now included in OSHA regulation, whereas it used to never be addressed. In rope descent, a descender is usually attached to a seat board, at least the way that it's used here in the United States, the way that it's called out in the regulation. The descender is usually attached to the seat board, and the person sits on a seat board. There is also some means of conventional fall protection as a backup, usually a dorsal attachment with a typical personal fall arrest system as a backup. Typically, rope descent is down only. There's no mechanism or means for ascending rope or horizontal traverse or anything else other than a down only. In the OSHA regulation, as well as in industry best practice as specified by I-14, there are minimal levels of training specified. There's no scheme of evaluation or certification. There's just some guidelines as to, hey, if you're going to do this, you probably ought to be trained in these kinds of concepts. In rope descent, there is a 300-foot height limit unless the infeasibility clause is invoked. So what I mean by that is this actually came from the ANSI I-14 before it was taken out of commission. It says that unless there is no other way to do the work, you're restricted to a height of 300 feet off the deck. I won't go into that a whole lot because there's not a whole lot of justification for it, but just keeping in mind that this applies only to rope descent. The stabilization requirement, there is a stabilization requirement above 130 feet. Those of you who work in the U.S. market, you are probably familiar with the OSHA 8-point rule that came out while we were waiting for updates to the OSHA regulation. That 8-point rule included intermittent stabilization, much as you might use on a scaffold or powered platform. And so that's where that requirement came from. It's really kind of impractical from a use standpoint to do intermittent stabilization on rope descent because you've got to clean your stabilization behind you. But we won't go into that because this isn't a presentation about rope descent. There is a requirement in rope descent for certified anchorages, and there is a requirement for some means of rescue. Now, this is true not just of rope descent, but of all fall protection. But the requirement is repeated in rope descent. Now, how does that fare with rope access? How does that compare with rope access? In rope access, you know that we have dual interchangeable systems. Your primary rope can become your backup rope and vice versa at any given time. This is completely unique to rope access. The rope access backup must be a rope access backup system. It can't be a conventional system because if it was a conventional system, it would not be interchangeable between the primary and secondary. So that rope access backup, you need to use a true rope access backup system. And if you're not sure what that is, I'd suggest taking a class. The rope access needs to be multi-directional, so you have to be able to go up as well as down, usually horizontally as well. That's a key factor of what constitutes rope access. Rope access employs certified technicians who are certified to an accepted scheme that, again, we'll cover that in a little bit more detail in a moment. Oversight and management for rope access needs to be specific to rope access. It doesn't do just to have a fall protection competent supervisor supervising rope access, because rope access skills and capabilities are completely unique. So there are no overarching height restrictions in rope access, and there is always a self-rescue and partner rescue capability in any rope access system because of the way that technicians are certified. So OSHA acknowledges the differences between rope access and RDS. So for those of you who have expressed concern that rope access is eliminated by omission from the regulation, you can see that in the RDS definition it says rope descent systems do not include industrial rope access systems. So there is an acceptance, a general acceptance that industrial rope access systems exist. They're just not the same thing as rope descent systems. This is made even clearer in the preamble to the rule, which specifically states, as such, for example, 1910-27 doesn't cover or apply to industrial rope access systems. However, other sections of the final rule, including 1910-28, do cover industrial rope access systems. So again, there's an acknowledgement here that rope access doesn't have specific rules called out in the regulation, but it still needs to comply with all of the general requirements of the regulation. So I hope this isn't too confusing, but this is fairly key as far as being able to use rope access in the marketplace. So let's look at that visual representation again. Remember, there's several types of personal fall protection systems that are specifically called out in the regulation, but there's a whole big body of fall protection that provides the baseline for those systems. So first we're going to look at the rules that just apply to all fall protection as a whole. Now remember, all of these general rules will apply to every type of personal fall protection system, every type of fall protection that exists. These rules are baseline rules. They're requirements that apply to everything. The requirements are kind of mixed between Subpart D, which addresses the big picture aspects of personal fall protection, and Subpart I, which includes specifications and use criteria. So rather than taking it paragraph by paragraph, again, I've condensed some of the applicable requirements by concept. And the first concept that we're going to talk about are connectors, because they are such a hot button for people. Connectors are a stumbling block for many. The regulation specifically says that connectors have to be drop forged or pressed or formed steel or equivalent. We'll talk about this term equivalent later. They have to be corrosion resistant finish with smooth surfaces and edges so as to prevent damage to the system. They do have to be an automatic locking type. That means 2 separate consecutive actions in order to open them. So that's an automatic locking. They have to be tested to a minimum tensile load of 5,000 pounds in the longitudinal direction, so that's along the spine, if you will. And then the gate strength has to be proof tested to 3,600 pounds in all directions. So proof tested is kind of a hot button here for us, and we have submitted our concern to OSHA in this regard, that they did use the term proof tested to 3,600 pounds. And I don't believe that proof testing is really what they were after here. I think that they were just saying that they have to be certified or tested to 3,600 pounds in all directions. Typically, a proof test is a test that you would put on every sellable unit, and we certainly don't want to put 3,600 pounds force on every sellable unit that we send out the door. Not only would that cost a huge amount of money, it would make the carabiners much more, it would either make them terribly unwieldy or it would create potential damage, neither of which are all that desirable. Continuing on with connectors, in the use part of connectors, it says that you can't use them connected to any of the things in this list unless they're specifically designed for such connections. So it says you can't connect them to webbing, rope, or wire rope, to each other, to a D-ring, to a horizontal lifeline, or to any other object that is incompatibly shaped or dimensioned. Now this is an awkward statement because it says you can't connect them to webbing or rope or wire rope. You can't connect them to a D-ring to which something else is attached. There's some weird things in here that we obviously do every day. This is because the connector requirement is not just written for carabiners. It's written for snap hooks and D-rings and all other kinds of connectors. A connector is anything that connects something to something else. So in order to cover all of those bases in a single statement, they were very all-encompassing, and for example, many snap hooks are not made to connect directly to webbing or rope with the little tiny holes in them, and they're just not made for that. So those you don't want to connect to a rope because they're not designed for that. Carabiners are designed for that. The biggest concern that we're trying to get around with connectors is this concept of incompatibility. By incompatibility, I mean a shape or dimension that might cause disruption between 2 pieces of hardware. So in the photograph here, you can see where one carabiner might, if you got three hard links connected to one another, you might get a situation where a cross load on that gate or some sort of potential rollout is possible, and we want to avoid those things. So even though we've created a 3,600 pound gate, which is really cool, we don't want to test that gate by cross-loading our connectors on purpose. So we want to use the equipment properly and compatibly. Let's move on to vertical lifelines and lanyards. So the standard says that each employee must be attached to a separate lifeline. The minimum breaking strength of a lifeline for one person is 5,000 pounds for vertical lifelines and lanyards. Self-retracting lifelines and lanyards that automatically limit free fall distance to 2 feet must be 3,000 pound strength. MBS in the fully extended position. So there's a variation there. It's generally 5,000 pounds for a vertical lifeline or for a lanyard, but SRLs can be 3,000 pounds in the fully extended position. And then knots have to be inspected by a competent person or qualified person before use. Now I want to point out that this language is actually in the OSHA regulation. Knots have to be inspected by a competent or qualified person before use. The thing that's cool about that is that in the past, knots weren't always accepted by all jurisdictions. Now we have a federal regulation that says that knots can be used as long as they're inspected by a competent or qualified person before use. So that whole nonsense about knots no longer being able to be used is finally beginning to go away. Further on vertical lifelines and lanyards, they may not be made out of natural fiber rope, so no manila or sisal or hemp for those of you who are into that sort of thing. Polypropylene rope must contain a UV light inhibitor. You all know that polypropylene rope is particularly susceptible to UV damage, so there has to be a UV light inhibitor in polypro rope, and in fact, even with that inhibitor, it's wise to be very careful of polypropylene rope. And then any other soft goods, whether they're harnesses or lifelines or whatever, have to be protected from damage. Now that seems to kind of like a no-brainer, but the standard says it, so there you go. Moving on to anchorages. Anchorages for personal fall protection systems have to be independent of anchorages that are used to suspend employees or to suspend platforms on which the employees work. So that means that if you're using a personal fall protection system, such as a secondary backup for rope access, it can't be connected to your primary connection for your primary rope. Now that's something that nobody does anyway. It's just good practice, but here it's called out in the standard. Again, it has to be capable of supporting at least 5,000 pounds for each employee attached, or it may be designed, installed, and used under the supervision of a qualified person, in which case the 500 pounds requirement goes away as long as you maintain a safety factor of at least 2. Travel restraint, lines have to be capable of sustaining a tensile load of 5,000 pounds. That's for restraint. And then general requirements for personal fall protection systems. Fall protection equipment has to be used exclusively for fall protection, so you can't use it for hoisting one moment and fall arrest the next. Fall protection equipment has to that is subjected to impact loading needs to be removed from service, so there's a requirement for taking good care of your gear. And then systems must be inspected before initial use during each work shift. So before the system is used, it has to be inspected. Now again, that's just good practice, but it's again called out in the standard. And then equipment must be compatible. We talked about that already. Some more general requirements. The employer must provide for prompt rescue of each employee in the event of a fall. Now I'd like to point out on this one that having one guy on scene that is rescue capable only works as long as that person is guaranteed to never be able to get himself into a pickle. If he's the one that might need to be rescued, then you need to get somebody else capable and qualified as well. Personal fall protection systems have to be worn with the attachment point of the body harness located in the center of the employee's back near shoulder level. The attachment point may be located in the pre-sternal position if the free fall distance is limited to 2 feet or less. So again, you've got an allowance for a sternal attachment here, which is a big step up from previous versions of regulation, and then acknowledgement as well that the dorsal attachment is still considered the normal major fall arrest, but in a limited type condition, you can use a pre-sternal position, which is a big deal for rope access. So now what I've given you isn't really an all-inclusive comprehensive list, but these are some of the key aspects that you'll notice in particular as a rope access program manager as you're trying to comply with the general fall protection rules. So now let's move on to some specific requirements as they apply specifically to fall arrest. Now remember, personal fall arrest are kind of in the big scheme of personal fall protection systems personal fall arrest is just one type of system, and we're going to talk now about some of the criteria that pertains specifically to fall arrest. So in a personal fall arrest system, regarding the system performance, maximum arrest force must be limited to 1,800 pounds. That's 8 kilonewtons. So maximum arrest force has to be limited under OSHA regulation to 1,800 pounds, and it has to bring the employee to a complete stop. So just an 1,800-pound arrest force and then continuing to lower is not considered an acceptable personal fall arrest system. The maximum deceleration distance is 3.5 feet or 1.1 meters. And there has to be sufficient strength in the system to withstand twice the potential impact force. This employee should not make contact with, the harness should not make contact with the employee's neck or chin area. And we assume that the workers, for all the test methods, are between 300 or below 310 pounds. There are modified provisions allowed for 310 pounds or over 310 pounds, but that needs to be an engineered system. So as long as you have an engineered system, you can have workers that are heavier than 310 pounds. Now, note that in the absence of any other specific criteria for rope access, these rules do apply to the secondary backup system for rope access. Now, perhaps what you're doing now is more stringent than this, and that's totally fine. But you must operate at least within these criteria. Further on, personal fall arrest system, it's notable that on any horizontal lifeline that might become a vertical lifeline, the device used to connect to the horizontal lifeline must be capable of locking in both directions. So just kind of think about that and let that soak in for a minute. The device used to connect to the horizontal lifeline has to be capable of locking in both directions on the horizontal lifeline. And again, the systems have to be rigged so that the employee can't fall more than 6 feet. Now, I want to specifically bring up this or call your attention to this horizontal lifeline issue because I had a long conversation recently with a British rope access technician who argued strongly that because he was a certified rope access technician, he was exempt from horizontal lifeline regulations. And it's important to understand that this is not true. Now, the good news here is that OSHA's rules are really performance-oriented, and they're not a by-rote approach. You don't always have to have, for example, a dorsal attachment. But even as rope access technicians, when you're working within a specific type of personal fall protection system other than rope access, like fall arrest or horizontal lifelines, you do need to follow the regulations that apply to that system. So being a certified rope access technician does not exempt you from any regulation, nor does working in rope access. Using a rope access system does not exempt you from compliance with the rules that apply globally on that big white background there. Those global rules still apply for all types of fall protection. So now let's talk about OSHA's approach to rope descent systems, since this is something that's very new in the regulation. The requirements that they adopted come largely from the ANSI I-14 standard on window cleaning. And window cleaning is really the most common type of work in which rope descent systems are still used. Although many window cleaners are actually now using rope access, this allowance for rope descent does still exist, but it is largely used in window cleaning. Now, with the approach that OSHA has taken, again, keep in mind that it's the type of system that matters, not the workplace. So a window cleaner might use restraint, positioning, arrest, rope descent, or even rope access. Any of these personal fall protection systems is fine, but whichever one he's using, he must operate within the requirements of that system. So let's look at rope descent systems as OSHA sees system performance. Again, the anchorages have to be certified to 5,000 pounds, and there must be written permission to use. This comes from BOMA and the concept that on buildings, people were using a lot of things for anchorages that really were never intended to be used for anchorages. So there must be written permission to use the anchorage that they use. The use of personal fall protection system is required 4 feet or more above a lower level. Every employee has to use a separate independent personal fall arrest system. All components except for the seat boards have to be rated to 5,000 pounds, and the seat board itself has to be capable of supporting a live load of 300 pounds. Now again, if you're familiar with the old I-14 that has now been rescinded, you'll notice that a lot of these requirements come specifically out of that standard. Further on rope descent systems, as you're using rope descent systems, there is a 300-foot height limit. As we discussed before, that 300-foot height limit can be exceeded if there's no other way to do the work the way that it's written. Again, the reasoning behind the 300 feet, this is one thing that goes directly against OSHA's performance-based criteria. Really, I think what they were getting at was you want to be able to mitigate the potential for wind or being blown around on the surface, or you want to be able to ensure that there's not so much rope weight beneath you that your descender doesn't work anymore, or you want to be able to be sure that rescue is feasible. These are all the things that some in the window cleaning world have claimed in the past that limit the likely height to 300 feet, but we know that by using rebelays and other methods that you can solve all the potential problems associated with high heights if you do it in other ways. But in rope descent systems, as they're addressed in OSHA today, there is a 300-foot height limit. The equipment must be used within the limitations set by the manufacturer or under the direction of a qualified person. The training has to be in accordance with OSHA 29 CFR 1910.30. The system has to be inspected at the start of each work shift. There has to be proper rigging used, including anchorages and tiebacks, provision for prompt rescue, and the ropes have to be protected from potential damage due to contact with abrasive surfaces and edges. So again, this is all specific to rope descent systems. Again, regarding system use, intermittent stabilization is required at work locations whenever you're in heights above 130 feet. So that intermittent stabilization can kind of create some challenges of its own, but it again comes from the scaffold requirements, and it just kind of got sucked into this because of the 8-point rule. It's not allowed to be used when hazardous weather conditions are present. Equipment has to be secured by a tool lanyard or similar method to prevent it from falling, which is just kind of good practice anyway. Ropes have to be protected from exposure to open flames, hot work, corrosive chemicals, and other destructive conditions. Again, kind of good practice. Again, I want to point out that many of these requirements do come from ANSI I-14, and that document was withdrawn as a national consensus standard after the release of this Walking Working Surfaces document. Let's jump on to rope access again real quick. The requirement in OSHA's regulation for rope descent are not stringent enough to achieve the baseline safety and versatility of what we've universally established in the rope access community as appropriate for rope access practices. So as we've read through all of that, there's just no requirements in there that are stringent enough to meet the requirements for rope access. So we don't want rope access to be confused with controlled descent or with RDS rope descent systems. Rope access is a specific type of work that includes certified technicians, oversight and management according to SPRAT safe practices, rope access specific equipment, the ability to ascend, descend, or move rope to rope. System redundancy is absolutely key, and interchangeability is key, and that lends itself again to self-rescue and partner rescue of all the technicians. So every technician is capable of self-rescue and partner rescue. So how do we evaluate rope access as a personal fall protection system in the absence of inclusion in OSHA regulation? And I know this is the $64,000 question that many of us are asking today. The term equivalent is used throughout OSHA regulation, and it's actually called out in the new Subpart D in relation to meaning alternative designs, equipment, materials, or methods that the employer can demonstrate will provide an equal or greater degree of safety for employees compared to the designs, equipment, materials, or methods specified in this subpart. Now that's a really wordy way of saying that equivalent systems are okay as long as they are at least as safe or safer than the specific systems that are called out in the regulation. And I think that we can all argue easily that rope access, as it's defined, administered by SPRAT in accordance with ISO standards, rope access does provide equivalent. In fact, it actually provides greater protection than any conventional means or methods outlined in the OSHA regulation. So that's a good thing, but it only works as long as you're working within established rope access practices. So throwing somebody on rope and not using certified technicians, established practices, appropriate equipment, interchangeable gear, rescue capabilities, if you don't have all those things in place, then you're not using true rope access with equivalent protection. Now, some rope access standards that will get you on your way as far as knowing what you need to do to stay safe. I would refer you to the Society of Professional Rope Access Technicians. I probably, in fact, at the end of this presentation, I do have their website listed. SPRAT has downloadable industry consensus standards that are safe practices for rope access work, as well as certification requirements for rope access. So I would encourage you to download those and sleep with them under your pillow for a while if you haven't already done that, and get to know those well. SPRAT standards comply with the ISO safety requirements for rope access. So ISO stands for the International Standards Organization, and ISO, under the auspices of its Fall Protection Regulation, standards, they do have specific documents relative to rope access, and the SPRAT criteria do follow those. In the United States, there is also the ASTM E2505, Standard Practice for Industrial Rope Access and Building Maintenance, and we mentioned that one earlier. And then there is the ANSI Z459, which is a pending document covering safety requirements for rope access. Now again, the ANSI Z459 is an outgrowth of ANSI Z359, and it's working under the auspices of that committee. It will be voted on by that committee. It simply adopted a separate name, Z459, instead of Z359, to prevent potential confusion in the future if equipment is to be certified to ANSI Z459. We wouldn't want people taking equipment that is intended only for use for rope access and putting it into a conventional fall arrest system, for example. So the idea of working with Z459 within the context of Z359 is much the same as the ISO standards, the ISO rope access standards, working under the auspices of the Fall Protection Committee. We want them to complement, not try to replace, but complement traditional and conventional fall protection methods. We're understanding that we're going to have to work alongside one another, and sometimes you're switching back and forth between systems, and the more our equipment and our concepts can be harmonized, the easier that's going to be for you to do as both an employer and an employee. So rope access is defined in ANSI Z459 as a work method consisting of appropriate equipment, adequately trained technicians, and a work plan, all of which together result in a two-line system that accommodates descent, ascent, and partner rescue, wherein the primary and the backup system are completely interchangeable. So that's rope access. All of those things need to be included in order for it to really be a true rope access system. To jump on a rope and call it rope access just because it's a rope is like tying your shoelace to a D-ring and jumping off of a platform assuming that that's fall arrest, but it doesn't comply with fall arrest rules, so it's not really fall arrest. Z459 recognizes rope access as a unique high-level skill, and it includes technician competence, rope access specific equipment, and interchangeable systems, as well as appropriate supervision. And the idea here is to create separation between rope access and rope descent systems for the clarification and training purposes of people who are using it in the field. We want to harmonize rope access with the overall comprehensive managed fall protection plan, and we want to be consistent, as we have been, with internationally accepted rope access practices such as are found in the ISO standards. In the ANSI Z459 standard, we try to acknowledge and provide guidance for equipment and systems that are not commonly found or accepted in conventional fall protection methods. And we can use that equipment because of those highly trained and competent rope access technicians. The contents of the ANSI Z459 standard as it exists today in draft form, it's out for ballot in draft form at the moment, so it could change before it's finished, but the table of contents as it reads today is scope, purpose, and application, definitions, requirements for program, system, and components, qualification systems for specific gear, marking and instructions for specific gear, guidance on inspection, maintenance, storage, rigging, and training for both simple systems and complex systems. And if you don't know what simple and complex are, you'll find that in the ANSI standard, in the ISO standard as well. We're harmonizing the Z359, Z459.1 with Z359.2, which is the guidance that ANSI gives for the overall comprehensive managed fall protection system. Now, in that Z359.2 that came out last year, there are training requirements specific to rope access. There are training requirements for an authorized rope access person and a competent rope access person that correspond more or less to level 1 and level 2. So that already exists today in ANSI Z359.2. Now, one of the things that Z359.2 does that is a little bit different from what anybody else in the rope access world does is they use the term as applicable in relation to training guidance. So in ISO and in SPRAT, there's always a baseline requirement that's applicable at each level of performance, and technicians are certified accordingly. In much of the Point 2 document, through all of the fall protection methods, it basically has a laundry list of potential things that you might want to be trained in if you're using certain types of techniques, whether they're fall arrest or restraint, etc. And it says, to the employer, you need to train people in these things as applicable. In rope access, we say the baseline requirements for level 1 are applicable to all level 1 technicians. The baseline for level 2 are applicable for all level 2 technicians, and so on and so forth. In fact, that's the whole reason that SPRAT was formed, was really to create consistent, measurable criteria by which technicians can be measured to determine their level of skill and knowledge and competence. So if you put as applicable in there, the whole concept of that baseline constant goes away. And ISO, I'd like to point out, maintains the same perspective. It's not unlike certification of equipment. You wouldn't want me to say your ropes, connectors, and harnesses should undergo a test to confirm their performance as applicable. You want to know what the true baseline is. So we expect the same for the humans in our system. So SPRAT was established in the mid-1990s to inform and educate safety professionals, specifically regarding rope access. It's a member-driven organization. This is my SPRAT pitch here, just to make sure that you all understand that the Society of Professional Rope Access Technicians is an independent 501c3 organization that functions separately for the purpose of certification of technicians to ISO standards and to that level. I as PMI, gain nothing from telling you about SPRAT, but I, as a professional working at height in the field, gain everything by telling you about SPRAT, because the safer we all are in the field, the better the industry will be as a whole. There are other certification organizations that are perfectly acceptable. The ARAA in Australia, IRATA in the United Kingdom, SARA in South Africa, FESAT, SRAA, HKRAA, and so on and so forth. The key is to ensure that any rope access certification standard that you're using, any certification scheme that you're using, needs to be compliant with ISO standards. So, keys to safe rope access are grounded in both employer responsibilities and technician responsibilities. The employer has to be committed to an appropriate rope access plan. He has to be committed to using certified technicians, and he has to be committed to appropriate oversight using rope access certified supervisors. Technicians likewise need to maintain their certification. They need to work to the employer's plan using acceptable techniques and equipment such as they're trained and certified on in the first place. The ISO standard provides guidelines for both the employers and technicians, and it's that team effort that really results in safety. Any rope access management system has to have procedures in place for the employer to manage the program using competent supervisors, certified technicians, and an established plan of work. Now, education and training is an essential part of what's kept the safety record of rope access so stellar, and so I'd like to just drive home the fact that certification is one of the main things that you can do to ensure that that certification or that safety level is maintained. In many forms of fall protection, engineers seem to be trying to remove the human factor from the equation. And in rope access, we not only accept the human factor, we embrace it. We know that a well-trained, competent technician working under proper supervision and using established methods and systems is the safety manager's greatest asset. It's the safest thing that you can do. So if you're interested in using rope access as part of your comprehensive managed fall protection program, be sure you start on the right foot. Education is foundational and key. Seek out appropriate certification and ensure that both technicians and managers are properly trained. Periodic refreshers. There are a number of training organizations out there that will help both certify and refresh your technicians. And here I'm going to insert a shameless plug for my book that was recently published by Wiley. It's the only reference manual of its kind for rope access, and it covers everything from regulatory guidance to equipment, systems, and pre-planning for rope access. And it's available from PMIrope.com or from Wiley. I'm afraid we're out of time for today. I'm actually a minute over of my time. I wanted to give 15 minutes for questions, so I'm going to need to wrap up here. But if you have any questions, I will be happy to answer those now. So, Jeff, have you been keeping tabs on any questions that might be coming in?
Yes, I have. And yeah, just to remind anybody, if you have any questions, type them in the questions function area there and send them to me now. I do have one question for you here. The question is, a lot of people come to us asking about fall protection competent person training. They want to know how long this course needs to be. Some say they can get the competent person card online. What are your thoughts? Obviously, one more addition. Obviously, OSHA doesn't give any timetables for competent person training.
Yeah, and that's a really, really good point, and it's a very common question. There's a lot of confusion around the concept of competent and qualified, and oh my gosh, I didn't really go into that. I'll do a live broadcast on that this year or this week. Just because it is something that comes up, the difference between competent and qualified and what it takes to be one. But specific to your question, there is no specific amount of time for a person to become a competent person or to receive competent person training. If you ask me, my answer would be it takes a lifetime. The competent person is not designated by a third-party certifier or trainer. The competent person is can be designated only by the employer. So the employer decides what makes you competent. So or what makes any of his employees competent. And remember that a competent person is a person who is trained to recognize potential hazards and take corrective action. And it's a little bit more complicated than that, but that's the basic definition, is that they can recognize potential hazards and take prompt corrective action. So what is it going to take in your workplace for that person to be competent? And so when you talk about fall protection, remember we talked about a half a dozen different types of personal fall protection systems. You can't be a competent person, you can't receive training in one of them and then assume that you're competent in all of them. So if you have a competent person, a person trained that has received what you believe is sufficient training to be a competent person in say fall arrest, and you send them out on another job to do positioning, they may be an authorized person, but they're not a competent person unless they've received the training and have the knowledge to recognize potential hazards and take prompt corrective action. So any given person in an organization might be a competent person in one small sliver of what you do, or they may be a competent person in several aspects of what you do. And what it takes to become that is defined A, in your comprehensive managed fall protection program, but B, I would advise you to look at the ANSI Z359.2 for that list of guidelines that basically it calls out, if you're going to do this kind of work, here are the things that you might want to be trained in. That's kind of a great guidance document for different types of work. Competent person for rope access is generally accepted as a person who has received their level 1 certification. So level 1 certification in rope access is basically considered a license to learn. It's not the be-all end-all. It's the authorization to go out there and work under the supervision of somebody else to perform work. I hope that kind of answers your question.
Okay, and this next question, I believe you answered it after the question was asked, but maybe you can just give us some bullet points. And there's confusion, it seems. Is rope descent not the same as rope access? And what's the delineation there?
That is a fabulous question, and I really tried to spend a bulk of time on that today because there is a lot of confusion about that. And a lot of people believe that as soon as you throw a rope into the system, it's rope access. And in fact, I read in a newspaper article the other day about a rescue that said, and the rescuers had to use rope access to get the subject to safety. And it's like, no, they didn't. They used rescue techniques. There is a difference. And so the things that delineate rope access really are that certified technicians, appropriate supervision by competent personnel that are specifically trained in rope access, the use of rope access specific techniques that involve a primary and secondary system that are fully interchangeable and that allow the technician to go up, down, sideways, and perform rescue.
Okay, thank you. The next question is a confirmation question. It says, to confirm, rope access hold on one second, does not fall under the 300-foot height, correct?
Great question. And I'm just going to switch to another slide here so that if you guys want access to contact information, it'll be sitting here in front of you for the next couple of minutes. To be specific, rope access does not fall under the 300-foot rule. The only thing that falls under the 300-foot rule under the new OSHA regulation is rope descent, is RDS systems, because that's the section of the regulation that it's called out in. So remember that big white canvas background that we called all of fall protection, there's nothing about the 300-foot rule in there. In positioning, there's nothing about the 300-foot rule in there. In restraint, there's nothing about the 300-foot rule in there. Fall arrest, there's nothing about the 300-foot rule in there. Rope descent, there is something about the 300-foot rule in there, and then the unnamed methods would, again, just flow back to that big white canvas that you would be subject to the general requirements.
Okay, great. Next question. Are 16 kilonewton carabiner gates required or recommended for rope access under the new OSHA regulations?
This is a fun one because I get this all the time. People say, well, I'm using rope access. I can use screw links or I can use any gate I want. And under SPRAT, yes, you can. Under ISO, yes, you can. Under OSHA, no, you can't. Those carabiners, those 3,600-pound gate, 5,000-pound longitudinal strength, and auto-locking mechanism all fall in that big white canvas of fall protection. They're foundational. All parts, any fall protection that you're using, you have to use a compliant connector, and that 3,600-pound gate is key. I'm sorry to say that, because I'm not a big fan of the 3,600-pound gate either, to be quite honest.
Okay. Next question. Is there an industry standard or best practice to the prompt rescue for a worker in distress? I assume using fire department technical rescue team would not be sufficient rescue plan.
That's a whole nother webinar, and we'll do that one later. But the simple answer to your question is prompt rescue is defined by OSHA as fast enough to prevent any further harm from occurring. So, for example, in an electrified environment, it might be as little as 6 minutes. In a suspended condition where somebody's hanging unconscious, it might be as little as 15 minutes. If it's a situation where somebody's pretty mobile and capable of wiggling around and they're just kind of stuck, you might get away with 20 or 25 minutes. There's really no criteria that specify how fast is fast enough. But there are studies that have been done to show how long it takes the local emergency responders to get to your doorstep, and then you have to assume that they're going to take even longer to get to your subject. And 15, 20, 30, even 40 minutes is, in most cases, optimistic.
Okay, we've got a couple more here. Can you define fully extended position with regards to an SRL?
Fully extended position would be its maximum length. So when you extend an SRL out to its fullest length, that's its weakest or potentially weakest configuration. So when it's at its maximum usage length, it has to be at least 3,000 pounds.
Okay, great. Next question. How does the new OSHA regulation address working at height for arborists?
That's a great question, and the answer is it's in a whole nother section. Arborists have their own rules, which we hope someday will be harmonized in terms of at the very least equipment, if not performance requirements. And again, I really like the way that OSHA's taking things with performance requirements, instead of saying, you can't fall, whatever. It's you have to attach your attachment onto the dorsal, or you have to. They're not telling you how to do it. They're just saying you need to keep the person safe. And here's the maximum force that they can withstand, or here's the position that they have to be in. And I think that's a much better way. And I think it will roll across to other approaches and other types of work at height.
Okay, great. And here's one more. What are your thoughts on suspension trauma? And do you rig to rescue, which is what we are taught in the UK?
That's a good question. Because suspension trauma has taken a lot of beatings over the last several years. Paul Seddon came out with his article some years ago, probably 15 years ago was it now, where he researched previous research to determine what kinds of potential hazards there might be, and we know of at least a couple of deaths that were unexplained causes. The only logical thing that they could come up with was this suspension intolerance kind of concept. So what I know about suspension intolerance and what I know about suspension trauma could be written on the head of a pin. I don't know much about it, and I don't know much about it because nobody knows much about it. Even the medical community that studies it in depth, they will argue for days over what the mechanism of injury is, and why it happens, and what happens, and how soon it can happen, and who it's going to happen to, and why. And the reality is that we don't know exactly what it is, and we don't know exactly why it happens, but what we do know is that when a person is suspended, motionless, for an extended period of time, that bad things happen, or can happen. They don't always happen, but they can happen. And so it is absolutely prudent to rescue somebody as quickly as possible. The second part of that question is kind of related, and that is, do you rig for rescue? And absolutely, rigging your system, your primary and secondary ropes in such a manner that you can simply lower a person off rather than or even raise them, but rigging a rescue system into your access system is absolutely a brilliant concept. It's not always possible, so I would caution you against saying anything like, you always have to rig for rescue, or that's the only way to do it, or what. That isn't the only way to do it. There are other ways to do it, but when you can do it, it's an absolutely brilliant solution.
Okay, great. There was a comment to add to that Dr. Roger Mortimer has done some recent work on isostatic intolerance. So I guess there's some work out there from our friend Dr. Mortimer.
Yeah, and in fact, if I'll go back to my shameless plug for my book, I actually quote him in that book. Because I think that he takes probably the most balanced approach to it. He's not trying to prove or disprove anything. He's basically acknowledging and telling us to make good decisions.
Great, and there were a number of questions on where can I access this? Is this being recorded, this webinar? It's very valuable material so that I can pass it on to other people. And I just want to let everyone know that you can go to www.pmirope.com, and this whole webinar will be available soon for you to access at any time.
And Jeff, I'd like to just let you know you're getting some feedback in your sound.
Okay. Well, we're going to wrap it up here. And Loui, I would just like to thank you for the very valuable information that you provided during this webinar today. And thank you for all the attendees for joining today's PMI Technical Webinar Series. Like I said, this webinar has been recorded and will be available soon at pmirope.com. Thank you very much for attending. We hope to see you next time. Take care.